Assalamualaikum and a very good day. I am Johanna and today I am going to present my paper for Seminar STEM 2024, which is entitled Spatial Variogram Models for Diameter at Breast Height and T Height among Stick Stands specific to Solomon Clone in Tawau, Sabah, Malaysia. So I will begin with the contents, which we will start with the introduction of my study, followed by the material and methods, and then we will talk about the results, and finally the conclusion. So this study is about thick trees, which are scientifically known as Tectona grandis, a sought-after topic in the research world and has always had its volume at the center of the attention. However, diameter at breast height, or in short DBH, and its tree height are as crucial as it is the rudimentary measurement that results in its volume. So this was a study that was instigated by Enterprise Corporation, where the initial purpose was to do a research in mass cloning of tick. So they had 15 different genotypes, and it was done in the year 2000. But then this study is a continuation of that mass cloning study, whereby we would like to find the best model to represent the growth of its DBH and its height. So this study aims to show that there are topological effects towards a tree's height and DBH, specifically in its spatial information. So this study is based on one block that is dedicated to Tectona grandis, and it is managed by the research and development team of Sabah Softwood Berhad in Brumas, Tawau. It was observed over the span of 12 years, located on the road to Tawau, Brumas. The trees were planted using a randomized complete block design with 4 contiguous replication comprised of 2 rows each of 30 plants and 15 different genotypes. Each trees was spaced 4 by 4 meters apart, resulting in 625 stems per hectare, and since there are over 5 hectares in this block, so it is resulting in over 4,000 trees. However, the assessed rows were only the 11th to the 20th row, corresponding to 80 plants per clone. All in all, 1,200 trees were collected, but considering only the Solomon clone, since it is the clone that is thriving the best, so we are only left with 451 trees. And then, since it is a spatial method, we need georeferencing, so only 432 trees were managed to be georeferenced and we during the 6th year plot. So the variogram, the experimental variogram that we use in this study is the theoretical exponential variogram and the theoretical spherical variogram, where we begin by plotting the empirical variogram first, and then from the empirical variogram we try to fit the exponential variogram and the spherical variogram into our data. Then we run cross-validation, where the RMSE, the root mean square error, and the R squared were calculated. We did some graphical observation and scatter plot of errors, and histogram of prediction errors are then plotted. And to show that the effect of topological features on growth, we also performed ordinary kriging, showing estimates of growth given spatial model selected on topological map simulated by RStudio and georeferencing done by ArcGIS. So with the initial plot of the empirical, as you can see these graphs here on the 2A, 2B, 3A, 3B, 2A and 2B representing the height variable, 3A and 3B representing the diameter at breast height variable. So the dots that you can see are calculated by using the empirical variogram, whereby the lines are done by fitting the exponential model and the spherical model into the empirical plots. So as we can observe, both models showed early convergence towards the range. However, the exponential model in 2B for the height variable shows a smoother curve before approaching its range, also suggesting that the nugget should be closest to 0. While for the diameter at breast height, both models exhibit smooth curve nearing the empirical variogram plots. And then we further on calculated its RMSE and R squared to see the error count. And for height, the RMSE, the exponential model suggested a lower error count. And for R squared, the exponential model also suggested a count that is closer to 1, whereby if the count is closer to 1, then it exhibits the actual model closer. So since 0.32 is higher than 0.30, therefore exponential model for the height is better. Whereas for the diameter at breast height also showing exponential fitting the plots of the empirical variogram better. Whereas for the plot of scatter plot of the error, the observed versus predicted error and the prediction errors, all four plots showed very similar performance, indicating that both models will perform similarly when it comes to prediction accuracy. But only the obvious difference that can clearly be seen is that the histograms for the exponential model is slightly higher peak at 0, indicating concentration errors around 0, which also means it has a better prediction accuracy. Whereas for the diameter at breast height, also exhibiting similar plots, but again for the histogram, it has a higher concentration around the exponential models 0, indicating that it is the better model when it comes to overall prediction accuracy. Then we proceed on to perform ordinary kriging. And these plots here shows the topological effect when using different experimental models, and it shows that the spherical model suggests that the tree's height will range around 17 to 24 meters, and it will be taller in the south, while shorter trees are concentrated in the center of the block, and that the preferred model, the exponential model in figure 6b, shows that the tree height should be about similar throughout the southeast side of the block. Same goes for spots of trees that are taller than usual in the south part of the block. Whereas for the diameter at breast height, the preferred model, the exponential model, also shows a bigger diameter in the south side of the block, and suggesting smaller diameters of trees in the northern side of the block. So we've come to the conclusion whereby the study shows how different experimental variogram models affect the estimation of the variable. With both height and diameter at breast height, exponential model was proven to be the better model to estimate growth of the teak trees. Prediction errors plotted showed very similar patterns, but obvious difference with the exponential model always shows a better prediction accuracy. When ordinary kriging was performed throughout the block, both models showed different patterns. Preferred model and the exponential model showed precision, even considering small spots of shorter trees and taller trees of the height variable, and knowing the possible outcome of the growth can help yielding process of these trees when it's time for yielding. It will help the team plan better for the yielding process to meet required demand at that time, and having a better yielding process can save time, can also save money, giving a better and more responsible deforestation process. And after deforestation, reforestation with a better plan can be done, knowing which area of the block will thrive better, having better spatial dependence based on the Kriging map that has been shown in figures 7a and 7b. So that is all from me. Any questions will be welcome. Thank you very much.